Hello everyone, this is Jay from BTYT Tech Library. Today we are going to use Exposed, a SQL library for Kotlin, to lay the foundation for integrating the Ktor Task Manager service with a relational database. Go to the Ktor project generator. Enter com.ptyt.ktor-expose-task-app as the project artifact name. In the plugins section, search for and add the following plugins by clicking on the Add button. Routing, Content Negotiation, Kotlin X.serialization, Static Content, Status Pages, Exposed, and Postgres. Click the download button to generate and download Ktor project. Okay, now we are ready to code. Ready when you are. Let's code along. First, let's delete the auto-generated sample code that is not used in this session. Go to source main Kotlin folder and delete the ct schema.kt and users schema.kt file. And open the databases.kt file and remove the contents of the configure databases function. Next, navigate to source main Kotlin and create a subpackage called model. Inside the model package, import the task.kt file from the former session. As in the previous session, we will create an in-memory repository. However, this time, the repository will implement an interface so that we can easily replace it later. In object-oriented programming, polymorphism is the provision of one interface to entities of different data types. The concept is borrowed from a principle in biology where an organism or species can have many different forms or stages. There are several commonly recognized major forms of polymorphism out there, in this case, subtyping. In the model subpackage, create a new task repository.kt file. Open task repository.kt and add the following interface. Create a new fake task repository.kt file inside the same directory, and add the following class based on task repository from the previous session. The code we will implement together is not much different from the previous RESTful API session, so let's first look at the important concepts required for introducing a database. As Spring Framework's documents, dependency injection is a process whereby objects define their dependencies only through constructor arguments, arguments to a factory method, or properties that are set on the object instance after it is constructed or returned from a factory method. The container then injects those dependencies when it creates the bean. This process is fundamentally the inverse of the bean itself, controlling the instantiation or location of its dependencies on its own by using direct construction of classes or the service locator pattern. Code is cleaner with the DI principle, and decoupling is more effective when objects are provided with their dependencies. The object does not look up its dependencies and does not know the location or class of the dependencies. As a result, your classes become more easier to test, particularly when the dependencies are on interfaces or abstract-based classes, which allow for stop or mock implementations to be used in unit tests. DI exists in two major variants: constructor-based dependency injection and setter-based dependency injection. In general, constructor injection is preferred due to its merits related to immutability, but sometimes setter injection is required depending on how it is to be used in unit testing. Okay, now we know the theory. Let's use it. Open the serialization.kt file in source main Kotlin. Import the application.configureSerialization function contents from the previous session and apply the constructor-based dependency injection. This is the same routing that we implemented in the Create RESTful API session, except that we are now passing the repository into the routing functions as a parameter. Because the type of the parameter is an interface, many different implementations can be injected. Open the application.kt file within source main Kotlin. Replace the module function with the implementation following. We are now injecting an instance of our fake task repository into configure serialization. Our long-term goal is to be able to replace this with a Postgres task repository. The client page also does not have many big differences from the previous session. Let's reuse it and implement the index.html file in source, main, resources, static together. Now it's time to manual test. Since we are using in-memory repository, let's comment out Postgres configuration in source main resources application.yaml file. Run the app and access to localhost port 8080/static/index.html. Unit tests are also quite similar with the previous sessions. So let's focus on how to use the derived class to apply dependency injection on unit test. Open the build.gradle.kts file and add the following dependency. In IntelliJ IDEA, click on the notification Gradle icon on the right side of the editor. Go to the source test Kotlin and open application.test.kt file. The code we are going to implement is almost identical with create a RESTful API session. So instead of fully implement it, let's import the source and practice on application settings. Good. Today we introduced the in-memory repository to our Task Manager service and checked out the concepts of polymorphism and dependency injection and applied them together. For those of you who have been waiting patiently for the introduction of a relational database, in the next part we will learn about the DAO design pattern and object relational mapping along with the introduction of a PostgreSQL database based on the current code.